Welcome to the Stormsurf video surf forecast for the week starting Sunday, October 15th. Looking at significant wave heights for the North Pacific Ocean, we don't see a whole lot going on, but that is hardly what's coming. So enjoy the calmness while it's here. It looks like a more active pattern is developing. As usual, we'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough. That is a dip in the jet to the south. And we don't see anything like that. But what we do see is winds pretty healthy, coming off of northern Japan, moving back further south. They were displaced up to the north here most of the week. Now looking like a little bit more of a normal position. And winds, what is that, 3 different colors, so 160 knots over the dateline. Pretty respectable. And flowing towards the Gulf of Alaska. No obvious splits, but no troughs either. So this is called a zonal flow when it's kind of running just basically flat west to east. But normally in these situations at some point a trough does develop. So let's sort of put this in motion, see where we're at. And there you go. Right come Monday, we see a little bit of a trough trying to organize in the Gulf and more energy developing over the dateline. And here we go, 190 knot winds developing over the dateline. South of the Aleutians come Tuesday. A little bit of a split here, kind of a cutoff low. Also northeast of Hawaii here, not doing a whole lot. And then you see a pretty well-defined trough. That is right here. So that would set up a counterclockwise flow aloft in the Gulf of Alaska. That is the hallmark of low pressure, and typically that'll happen both in the upper levels of the atmosphere and down at the surface. Of course, low pressure makes wind. Winds generate seas. Seas, when they radiate away from the fetch area, turn into swell, and swell makes surf when it hits your beach. So there we go, 190 knot winds come Wednesday morning, pushing through the Gulf, providing some decent support for gale development. And even better as we move through the day, the trough starts deepening more, and still with healthy flow pushing down. It's that flow pushing down into it there that really gets the, this quadrant of the storm, the west and southwest quadrant, and that's the quadrant that would make swell relative to the U.S. West Coast and Hawaii if the trough were a little bit further off to the west here. Anyway, we'll roll this out, and you can see Wednesday, Thursday looking pretty good. Trough, something probably going on. And notice, back to the west, the jet does not split, but actually starts re-energizing again come Friday. Another little bit, very gentle trough here come late Friday into Saturday, developing over the western Gulf of Alaska. That should help support gale formation more. Now, notice a little bit of a ridge. When it pushes north, that's a ridge. That promotes high pressure down below it right there. Okay. Another trough developing in the western Gulf comes Sunday, and where are we? We're out. Here we are. 180 hours, well-defined trough. Certainly looks like a healthy fall pattern. Finally setting up for the next week in the upper atmosphere. Let's go see what goes on or what's forecast down at the surface. So here we are, surface level pressure, surface level winds, high pressure in the southern Gulf of Alaska right now. Was generating a pressure gradient along California, generating northwest winds, and that was made wind swell nonstop for the past week. Also, off the south side of the high, generating high, of course, circulates clockwise, and that's what's driving trades. Abnormally strong trades pushing into Hawaii, generating wind swell along east-facing shores there. And that has been going on for a bit and is expected to continue. We'll just sort of keep your eye there if you're wanting to know what's going on. Anyway, so come Monday, low pressure starts developing over the dateline region associated with a developing trough there by Monday night. 45 knot winds south, free and clear of the Aleutians. We know there's upper level support for a gale. Sure enough, 45 knot winds continue into Tuesday night, moving through the Gulf. 50 knot winds, that puts it at storm status Wednesday morning. We know the trough right there is dug out pretty well. Another low pressure system here, some sort of a tropical system supposedly forming off the Philippines. We'll believe that when it happens. Anyway, notice this low just inching its way towards the U.S. West Coast. High pressure trying to keep a lock on things so the storm door doesn't open, but not for the Pacific Northwest. They would probably get some rain out of this event. Another gale low come Thursday, developing off the Kuril Islands, pushing to the dateline with 40 knot winds as our system over here dissipates. Tropical system continues off the Philippines. We have an active pattern here for sure. Come Friday, next gale moving over the dateline into the western Gulf. Strong system supposedly south of Japan, lifting north. We'll just sort of roll this out. You can see the gale system fades out, and here comes something tracking north, hopefully, just hopefully, if it even forms, getting caught by the jet and pushed off to the east. So, a significant change from what we had a week ago. Let's go take a look at the wave models. And as we saw before, significant wave heights, North Pacific Ocean, not a whole lot going on, but we'll put this into motion. Here comes our first gale pushing over the dateline come Monday, building 28, 29 foot seas. What's that? 29.6 to be precise. 30 feet on Tuesday. It's not till Wednesday that things are supposed to wind up. There you go. Small area of 43-foot seas in the core of this thing, maybe 42-foot seas. Pretty displaced a bit to the north, though, really targeting the Pacific Northwest, and it falls through the Gulf. Still good for swell the whole way down the U.S. West Coast into Baja. Number 2 system starts developing off the Krill Islands with 30-foot seas, getting to 32 feet, making it to the dateline, while our tropical system, if you believe it, spins off the Philippines. Roll this out some more. We're into Saturday. The low moves into the Gulf, starts fading. Certainly swell for Hawaii from that. Also the U.S. West Coast, though probably smaller. And continued, what's that, 22, 23-foot seas in the Gulf into Sunday. That should be good for a pretty good long run of surf if it were to happen as forecast. Tropical system pushing off to the north. You can't see it. It says 64-foot seas because, see the little black lines here, the isobars. It's so tightly wound it just turns into a black ball. But 64-foot seas supposedly buried in there. We'll believe it when it happens. But again, clearly, swell, not so much for the first system for Hawaii, but from the second system. First system, California, Pacific Northwest, and who knows what this third system is going to do. Let's go take a look down south. It is still active too. And here we are, significant wave heights for the South Pacific Ocean hindcast. We're going back a week. Okay, system developed southeast of New Zealand last Sunday, the 8th of October. Started building, small area 32-foot seas, south of Hawaii, lifting northeast. Sort of stalled, then regenerated. Here was its peak, 39-foot seas over a small area, but lifting pretty well to the north. And that swell is, in fact, in the water at this moment, pushing towards California, not shadowed as best we can tell, or the bulk of the energy not shadowed. Certainly not for Northern California, and certainly not for Southern California, and on down into Mexico, Central America, etc. They roll that out, and things kind of were quiet after that. Let's go to the forecast charts. Or actually, we just moved forward a day. Then starting Saturday, midday, Southeast Pacific, gale low developed right on the hairy edge of the Southern California swell window with 34-foot seas. Southern California, about 117, 118 west. This is at 120. Lifting north, right there at 118. What is that? 117.5. Okay, with 37-foot seas, and then starting to push off to the northeast. Small pulse of swell possible. Just keep your eyes on that one. Look at this other one. Whoops, that was it. Okay, small pulse of swell pushing north, probably mainly for Southern California, certainly for Mexico and further south. Now we direct our eyes back. We're back to Saturday. What was that, 24 hours ago? Tasmania there. System develops southwest of New Zealand. Small area, seas, builds to 38 feet. And then 40 feet, almost 41 feet, sort of falling southeast just a little. So just watch the line on this one. There you go. But then it starts lifting northeast a little. That was midday today. Whoops, midday today. And let's go to the forecast chart. Here we are. And then it starts fading from there. But certainly a small pulse of southwest swell, probably unshadowed relative to California. And we have had basically zero southwest swells this entire summer, even though it's fall now. All the activity has been the southeast Pacific. That's pretty typical of a La Nina winter, but we eked out a little pulse of energy here. We'll see what actually arrives. The other thing is, if the North Pacific is waking up, this swell will be completely lost, certainly in Northern California, even in Santa Cruz, those areas. If there's significant west or northwest swell, it just gets lost under that. Protected breaks in Southern California, though, could see energy from this system. So we roll this out. We'll just roll out. The short of it is there's nothing that we're aware of that's scheduled to redevelop. Little bits of activity. We're just going to roll this out here through the 180, and there you go. Pretty quiet pattern. North Pacific starts taking over. So for the next week or so, good mix of swells both north and south in the forecast. Let's go take a look longer term out and see what's going on. As usual, we'll start our analysis of the MJO, or actually the lack of MJO. La Nina, we'll just cut right to the chase. La Nina is in control. We've been saying this for a couple weeks now, and there's really been no change. But we'll look anyway, because sometimes you pick up some tidbits and you learn stuff. It's the daily and weekly monitoring of charts and noticing subtle differences in what's happening and then what's the effect on your beach, or what's the effect long term. All that stuff is important to know. It seems kind of boring sometimes, but you actually get a feel for the pulse and the rhythm of the atmosphere in the ocean. Anyway, so looking across the equator, West Pacific here, East Pacific here, New Guinea there. This is from the TAO buoy array. Buoys strung across the equator, used for monitoring El Nino. Trades in control. This is actual average wind speeds over 5 days. Trades from the east, strong over the entire Pacific. It is the Kelvin wave generation area, the area from 170 west to 135 east, 5 degrees north and south of the equator. That's where you really get a sense of the effect of the MJO, Madden-Julian oscillation, over the Pacific. And of course, the MJO, when in the active phase, helps support storm formation in winter months. Right now, we see east anomalies. Differences, the winds. So yeah, the winds are east. Is this stronger or less than normal for this time of year? And this chart tells you that it is stronger than normal. That is at least a sign of the inactive phase of the MJO, which tends to sort of suppress storm development. But we also looked on the charts and saw, well, there's some stuff going on, so that's not a 100% correlation. Either way, so anyway, we have the east anomalies here. Oh, we were saying this was the inactive phase of the MJO, but we also know the MJO is basically dead. So what this suggests is this is all being forced by La Nina, which is in control. Then we go to look at the forecast, and actually this is, so the whole planet on one chart. Blues and purples are easterly anomalies. Yellows are westerly anomalies. Kelvin wave generation area in between these two tick marks. You can see in September, strong burst of easterly winds. Another burst in, let's say, mid-October. And then here's yet a stronger burst. But notice it's not in the Kelvin wave generation area, which is really like right in between these two ticks. It's more off there, but still pretty strong easterly anomalies forecast for the entire week. This is all the hallmark of La Nina, prevailing stronger than normal easterly winds over the Kelvin wave generation area, tending to suppress storm development, tending to weaken the jet stream, and sometimes split it. Now, that doesn't mean that that's always true, because you do get surf during La Nina years, but the tendency is for weaker storms, less number of storm days, smaller swells, less, just not as conducive. El Nino, the exact opposite. More storms, stronger, more storm days, more swell days. Let's look at the MJO forecast. Here we are. Outgoing long wave radiation. Blues suggest less sunlight reflectivity off the ocean surface, meaning cloud cover, meaning the active phase of the MJO. And this sort of suggests that some active phase of the MJO is trying to set up in the West Pacific. This per the statistic model, because there's New Guinea there, and the Philippines right there, and you can just see over the next 2 weeks, basically in play, the GEFS model saying the exact same thing. This would be the first active phase of the MJO since March, if you would believe it. It's just been continuous inactive phase, non-stop, which helps explain why we had such a lackluster summer, because the MJO does affect the southern hemisphere, though the correlation isn't as strong, but clearly it was pretty strong this summer, and we'll see what happens. Anyway, and any active phase is a good thing. We'll take it. Upper level model sort of correlates that as well. Here is the Philippines there, Australia there, Peru right in this area. the equator, running in red across here. Greens are areas favorable for precipitation, suggesting the active phase of the MJO, and this suggests it's moving to the east as would be expected through, let's say, the first week in November, and then exiting the Pacific just on the equator. That's the only place that matters here. Exiting and out of the picture. Then at that time, the inactive phase follows. No big surprise. Coming into play, let's say, the first week of November in the far west Pacific and making its 4-week journey across the Pacific, and then an active phase following that. The interesting part about this chart is it's actually showing active and inactive phases. For 6 months, there's been nothing. The pattern's been directionless. Yes, if we have to deal with the strong inactive phase, as long as we get stronger active phase going with it, that means there's more energy in the atmosphere. That means at least there are windows to support storm development. We'll take that over what we've been suffering for the past 6 months. So we're going to show you this chart. You can see it's a mess and continues to be a mess, and something's going on with it, but there might be something that we can glean out of it. Supposedly, okay, so this is the whole planet on one chart. The dotted lines are the inactive phase of the MJO, Kelvin wave generation area, right in here. Supposedly, strong inactive phase in control. Don't know if that's true, because you can see how weak the MJO was. Now all of a sudden it just goes completely off the chart strong. The model took a dive in here somewhere. We suspect that's probably what's contributing to this. But we get past there, and then it starts looking more normal again come maybe the end of October. And it's suggesting that, you notice the yellows here, westerly anomalies, weak westerly anomalies supposedly developing. And again, kind of a weak MJO pattern biased towards the active phase as we get into later November, early January sort of thing, December, early January. Not sure whether to believe that or not, but we're showing just so you can see what's going on. The low pass filter, though, that's what we're really interested in. And this is showing, see this dotted line? That was right over the core of the Pacific, and has been for years, indicating La Nina. Supposedly, it's moving off to the Atlantic now, and a El Nino-like regime is setting up over the Pacific. Don't know whether to believe it or not, but if that's true, that would mean that the underpinning, sort of the foundation of La Nina, should start falling apart. And yes, we say falling apart now, it would probably take 4 months before you'd actually see it in the atmosphere, in something that would be recognizable in terms of, storm track or storm duration or anything like that. So that we're talking, February or so, maybe even later than that. Anyway, something to note. Let's move on. So we know some sort of La Nina is in play. At least we certainly sense it by looking at the data we've seen so far. Let's take a look at the ocean. Subsurface ocean, West Pacific here, East Pacific here. This is TAO buoy array. These are the position points of the buoys strung across the equator. Anchor lines on those buoys, sensors on the anchor lines. Tells you that there's warmer water, 29 degrees centigrade in the West Pacific, which isn't very warm at all, and much shallower warmer water in the East Pacific. We know the trades are nuking, have been nonstop, so what that tends to do is create upwelling in the East Pacific, take whatever warm water's here, push it off to the west. That's exactly the subsurface profile that we see. Looking at anomalies, differences from normal for this time of year, yeah, there's your warm water. Was it 0, maybe 1 degree above normal? So pretty much normal there. You want to see a big ball of warm water over here if you think any kind of El Nino is going on. When you see this as subsurface pocket of cooler water, that's a classic sign La Nina. Cooler water here along the surface, along Peru here, and this water we think is upwelling to the surface. We'll show you in a minute. There's another chart to look at. Another different version, a modeled version, you take the TAO data, use a model to fill in the missing gaps. You can see here's that big pocket of cool water, and you can see it reaching up to the surface here from, well, where is that? About 120 west to about 165. So Hawaii is somewhere there, north of there. So pretty much over the entire equatorial Pacific. Cool water from this pool somehow is getting drawn to the surface, probably because of upwelling, because the trades are nuking here, so that just drags that cool water right to the surface, and we'll see the impact of that in a minute. Another piece of subsurface data, sea level anomalies from the JSON-2 satellites. Strip out all the waves, tides, wind swell, whatever, and you see the ocean surface is 10 centimeters below normal right in this area. Negative anomalies typically suggest cooler water at depth. Cooler water at depth, kind of contracts a little, makes a divot, a negative divot on the ocean surface, and that's exactly what you got here. And the only thing you care about is what's going on at the equator. The rest of this, not so much. That means there's cool water at depth. And upper ocean heat anomalies, upper 300 meters last year. So this is West Pacific here, East Pacific here. Cooler than normal water. La Nina last year, weak La Nina. Then a little piece of El Nino developed in the springtime. Not really an El Nino, but just sort of an aberration. The last of the warm pool discharged to the east and then disappeared. Here we are, very weak warming. And here is the reemergence of La Nina for a 2-year double dip La Nina pattern. That's what we're doing. The question is this La Nina stronger than last year's? Last year's wasn't that strong, really. Looking at this chart, you go, no, if anything, it looks kind of weaker. Doesn't cover as much area, doesn't move as close to South America, but we have other data suggesting otherwise. So that leads us to surface level data. What is the surface temperature, sea surface temperature profile looking like? We see here blues, colder than normal along the Peruvian coast. We know there is upwelling going on. We know the trades are blowing over this entire region, and you can see that this cool pool is pretty well defined the whole way from South America out to 160 west. There's Hawaii there. That is a classic La Nina signature. Let's go take a look at the 7-day trend. And this is just what the temperatures are doing over the past 7 days. Are they getting warmer or colder? And this blue suggests colder right all along here. This is telling us that La Nina appears to be pulsing again. It does this. It'll breathe, sort of like the MJO pulses, inactive, active. And there's other things, La Nina and El Nino pulse too, normally amplified or modulated by the MJO. The MJO in negative phase is pulsing at least over the East Pacific and generating stronger normal trades, causing upwelling, drawing that cool subsurface water to the surface. So the trend is negative. And then you look at the wide view, the actual temperature profile, anomalies, differences from normal, and you see, of course, much cooler water all along South America, especially Peru, over the Galapagos, and this right here was it was strong. It backed off and got a little bit warmer the past week or two, and now it's starting to pulse again. Cooler water. This is classic La Nina signature. El Nino, you'd have warm water right here. La Nina, cool water right here. The yin and the yang, the two extremes of that oscillation. So this, and without getting into the data, suffice it to say, this looks far more pronounced than last year's La Nina, but not super off the top, just definitely there. You can't deny it. And here we go, sea surface temperatures for Nino 1.2. That's the area right there by the Galapagos and along Peru. Temperatures, pretty cool. There's 2 degrees below normal. That's the coolest pulse we've had, and that was as of 4 days ago, down at like minus 1.9 degrees below normal. So that's, so this is a noisy region. There's a lot of variability here, but definitely we're not on the El Nino side of the curve. We're on the La Nina side. And then here's the official Nino 3.4 monitoring region from 120 west to 170 west on the equator. You can see for sure from July, temperatures have been steadily going negative. We got down to about 0.9 of a degree below normal in, let's say, mid-September. Temperatures have been rebounding a little bit to, what's today, minus 0.2 of a degree. But we suspect that that's going to trend downward as we get deeper into the fall and La Nina gets better footing. So we've talked about what the atmosphere is doing, mainly in the West Pacific in the forms of the MJO, which has all been pretty much inactive, though it's trying to go active now. We've looked at ocean subsurface temperature, which certainly looks like La Nina. We've looked at ocean surface temperature data, which looks like La Nina. So let's go see what the atmosphere in general over the whole Pacific Ocean is doing and if it's responding to the changes in the ocean. And we see that, of course, in the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Positive numbers, and you can just scan down here. This is the daily index. Yes, quite positive today, 21.72. That's indicative of at least the inactive phase of the MJO, if not La Nina. The 30-day running average, you can see this. We got, let's see, we were at 3.74 or so, and the trend has been steadily upwards at 10.41. So that certainly would indicate the inactive phase of the MJO. The 90-day running average, that's really what you can use to look at the presence of La Nina. It takes all the noise out. A month ago, we were at 3.76. Now we're at 7.47. When this guy gets up into the 10 to 12 range, then I would say for sure we're in La Nina. And it certainly seems like it's going to get there if you just keep looking at the daily numbers. They're all, in the teens and low 20s. That will keep pushing both these averages more positive. It seems like La Nina for sure is a wrap for this winter. And then there's the ESPI index. Instead of measuring the difference in pressure over these two areas north of Australia and let's say generally around Tahiti area, this measures actual precipitation, which is a good measure of what's happening. Another way to measure what's going on the surface, if it's more dry than usual in this area, which is right above the Nino 3.4 region, your index goes negative. Right now it's at minus 1.59. It's been hanging there for weeks. Clearly indicative of a drier pattern, which is also indicative of La Nina. You can see in the chart here, pretty much dry right here. There's rainfall anomalies and a little bit drier. So all in all, a La Nina pattern appears to be shaping up. Sea surface temperature anomaly forecast from the CFS version 2 model, the final piece of the pie here. So interesting, here's the actual data. This is, again, that area 120 west to 170 west, 5 degrees north and south of the equator, on the equator. Actual temperatures were a little higher than what the model projected in October, so that sort of pulled everything up. But still, the model projects that temperatures are supposed to drop to about 1.1 degrees below normal in the December time frame. And then slowly start working their way up from there. At one point, this model was suggesting down to minus 1.5. A bunch of other models are not nearly as negative or suggesting that the cooling will be much more modest. But this seems like, it runs. We have access to the data for one. It's from a reputable source. And though this model tends to be more negative in terms of the sea surface temperatures than all the other models, there's like 10 or 15 different models, and they all compete and compare, and you can, measure them all together. This guy's the outlier, suggesting the most negative temperatures, but we're tending to go with that just because it seems to reasonably reflect what's going on at the surface, and it's kept up to date on a regular basis. So, the good news, looks like Northern Hemi swell is supposed to develop, maybe 2 of them, maybe 3 of them if we're lucky over the next week. And in the meantime, Southern Hemi swell is in the water pushing north, bound for California, not so much for Hawaii. Another system also developed under New Zealand, probably pushing some swell towards Hawaii and the U.S. West Coast. So a second Southern Hemi swell, small, on the way. Probably get lost in the Northern Hemi swell if it all materializes as expected. So take that, make the most of it, enjoy it. Long-term outlook still. The good news is, it looks like maybe an active MJO might be developing, which would help put a kink in La Nina, but still, the pattern clearly is La Nina dominated for right now, but we knew this was coming. No big deal. We'll survive one winter, and then maybe, if the MJO wakes up, at least that would put more energy in the atmosphere and start pushing us in the right direction. The thought is we'll get through this year's La Nina and then we'll fall into a more normal pattern, probably starting around May of next year, something like that. So just got to suck it up, make the most of it. Anyway, that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.